Yes, Nick.
How do I get off of this? Because it doesn't let me get off of this no matter what I do.
Hit second mode.
Press like everybody.
But I'll have to play around with it at a later time, so. Alright, so today we are starting with chapter 3. As it says here in 3.1, we're going to take a look at scatter plots. So basically what we're now going to be doing is, back in chapter 1, we were dealing with either categorical variables or quantitative variables, and we were graphing them. We'd collect information, and a lot of times it'd just be on one piece of information. Unless we were doing categorical pieces and we were starting to see if there were relationships between two pieces of categorical variables. Today, what we're going to actually now do is take a look at what we call bivariate data. So we're going to start to compare the relationship between two pieces or two quantitative pieces of data, and we're going to start to see, is there a relationship between them? So when we start to do that, we have to have what's called an explanatory and a response variable. Okay? The explanatory variable, lots of times if you think about this is your independent variable. So if you go back to like some of your science classes, you'd have like an independent variable and a dependent variable. Your response variable is your dependent variable. Its results depend on the independent variable. So we like to call the explanatory variable because it's explaining what's going on to the response variable, or what we're getting as a result. Your explanatory variable is on your x-axis, your response variable is on your y-axis. We do not interchange those. Okay. So, just one of the things that you should be able to do is, given any type of problem, you should be able to identify which is the independent or explanatory variable and which one is the response variable, if it has one. So, for instance, in these examples, we've got 3 of them right here. It says, for each problem, identify the explanatory variable, the response variable, if it's possible. So number 1, it says, Julie wants to know if she can predict a student's weight from his or her height. So the explanatory variable. So in this case, what's the independent variable? Yeah. So a student's height. We're using that variable to, wow, that A looked really weird, okay? To predict what? So we're looking at a student's weight. All right, on number 2, it says Jim wants to know if there's a relationship between height and weight. Do you know which one's the explanatory here and which one's the response? No, it doesn't say you're using one or the other to predict the other. So this one has no explanatory or response variable assigned. Sometimes that happens. Sometimes when you're taking a look at a relationship of 2 quantitative variables, it's hard to decipher which is predicting the other. This would be a case. Does height determine weight, or does weight determine height? They could influence each other. So when you go out and buy products and you like walk down the bread aisle, does price determine the quality of the bread, or does the quality of bread determine the price of it? They can sometimes be interchangeable, okay? But many times they'll be like number 3, where we're starting to do almost like an experiment. So number 3 says, how does drinking affect the level of alcohol in our blood? The legal limit in all states now is 0.08%. In a study, adult volunteers drank different numbers of cans of beer. 30 minutes later, a police officer measured their blood alcohol content, or levels. So the explanatory variable here, not just beer, but how are they measuring it? Okay, so it's the number of cans of beer consumed. So you need to be specific with identifying the explanatory and response variable. How are they actually measuring it? Okay. So our response what do they measure here? Yeah, the blood alcohol levels. So now, how do we go about analyzing an explanatory response variables? Probably the easiest way is to look at what we call a scatter plot. When doing a scatter plot, the biggest thing is we're talking about a relationship between 2 quantitative variables. You can compare categorical and quantitative variables at the same time, but you can't create a scatter plot in doing so, okay? So, what we do when we draw our graphs of our scatter plots, okay, is a scatter plot, most of the time it's in the first quadrant, doesn't always have to be because you could have negative values, but you have your explanatory variables on the x-axis, and you have your response variables on the y-axis. Once you do that, make sure you label and scale your axes accordingly. So make sure that you have scales for both. Okay? And then when you plot your individual data values, make sure you use the whole graph. Meaning you want to make sure when you graph it, if I just start graphing points here, it's taking up the entire graph. Doing something like this where you have all the data points just right here would be a bad example. Okay? You want to make sure that you're using your entire area so that you get a good picture of what's going on with your data. So what we're going to do today is we're going to do some scatter plots here today by hand, and we'll also show you how you can do them on the calculator to get a picture of what they look like. So go ahead and turn to the next page once you have the rest of this done. I know I see a few of you writing, so I'm going to wait a second. So, how to make a scatter plot on your calculator. Here are the basic directions of it. So we're going to use these directions right here for this particular example to do it on the calculator. So the first thing it says here, enter the data list in your 2 lists. Usually you put them in as list 1 and list 2. So let's take a look at this example and do that first step. It says the table below shows the data for 13 students in a statistics class. Each member of the class ran a 40-yard sprint and then did a long jump. make a scatter plot of the relationship between sprint times in seconds and long jump distance times. So now this one here doesn't say does one predict the other, but we're going to try to see what the relationship is. So I'm going to have sprint time be list 1 and long jump distance be in list 2. So what you'll want to do is take out your calculators, and we're going to start entering those data pieces in. So those of you at home watching this, I'm going to pause and go to unpause here. Alright, hopefully you have all your data into your list 1 and list 2, and now we want to continue the process of doing our scatter plot. So if I go up to my directions up here, it says on your calculator you're going to hit second y equals. That gets to that scatter plot menu, just like when we were doing a normal probability plot, okay? Or doing the box plots. What you want to do is select the scatter plot picture, which is that first picture on your screen. And then you want to make sure that it corresponds to the 2 lists that you want. So I grab my calculator here, slide this over here. So if I go second y equals stat plot. Now, the other thing that's not mentioned, but make sure your other stat plots are off and only the first graph is actually on. So I'm going to turn it on, or it already was, scatter plot. I want list 1 and list 2. So I had different lists in there. That can happen from time to time. Now, if I hit graph, I'm going to, none of my points showed up. Okay? And in the directions, number 3 says zoom 9. It's a wonderful little tool that you'll do quite a bit. So this gives us a picture of kind of what's going on with our data. Remember, X is sprint time, so as sprint time increases, okay, so as people run slower, okay, doesn't look like they're jumping as far, or their long jump distance is getting shorter. Okay? So, what's nice about the calculator is it gives you a nice picture, but sometimes you're still going to be asked to graph it by hand. So, down here in the bottom, I am going to draw a little sketch of this. So to graph this quick, or try to do it somewhat quickly, if I'm drawing one by hand, I'm so sorry, was there a quick question?
Oh, sorry.
Oh, was there something in your y equals, or?
Yeah.
Okay. Wonderful, perfect. All right, so here I'm going to have sprint time. And here we'll have long jump distance. So notice how I'm labeling my x and y axis. Now if I look at my sprint times, my lowest or fastest sprinter looks like about 5.1 seconds. The slowest was 9.5. So one of the things I can do when graphing this, okay, is I can do what we can call breaks in our graph. So to do a break, what I do is I just do a double slash, and I can start this at 5 seconds. So that the reader knows, and the person knows, that the distance from here to here is not 5. Because what I'm going to count now is by ones, going up to about 10 seconds. And I'm going to put a little space in here. So I might go 6, 7, 8, 9, then even extend that a little bit, 10. I might put little dashes here in the middle so I know where the halves are. Now I'm going to do the same thing for the long jump distances. The shortest distance looks like 48, and the highest 173, 184. So I'm going to break the graph there. I might start at 50. Actually, I'll go 40 since we have a 48. Better go 40. I'm going to count by tens, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 60, Ooh, 70, 80, kind of squeezing that. $140, $150, $160, $170, $180. So I'm going to have 1 point be a little bit in my grid here. So I go ahead and start plotting the points. So 5.4, 171. 5.1, 184, which was my highest. 9.5, 48. So I just take my time and I do each and every single point. 8.1, 151. 7.0, 90. 7.2, 65. 6.8, 94. 6.7 and 78. 8.0, 71. 5.7, 130. 5.8, 173. 6.3, 143. And 6.0, 141. I'm just trying to look for, I had a 6.0, 141. There we go, that's a little bit better. I got a little bit off there for a second. So the question becomes, does this picture right here look similar to what I have on my calculator? Does that look roughly the same? I have 3 points here, 3 points here, 2 points clustered here, or 3 clustered here and 3 here. The one's kind of sitting outside there. Big cluster here. So it looks like it's matching up pretty good. So everything looks pretty nice. How are we doing on the scatter plot? Am I going too fast? Hopefully not too terribly hard. Okay. So now the question becomes, how do I go about describing what I'm seeing? Okay. So it does seem like there's a distinct pattern going on here. You know, as sprint time is going up, as people run slower, okay, their long distance distance seems to be going down. So how do we go about describing this mathematically? Just like we would do shape center spread with our different types of graph when we had one variables, we have descriptors for scatter plots. So on our next page, how do we interpret our scatter plots? Yes, today is a 3-page note or 3 pages of notes. We're actually going pretty fast right now. So, how you go about doing it? Give you some basic steps here. First thing you want to do is just look at the overall pattern. Look for any striking departure. Basically, you want to look for any points that seem to be outliers, that are way off the overall pattern. In ours, it looked pretty nice. Alright? So then, there's 3 things that we look for when describing the overall pattern. We'll talk about direction. Okay? And the key words that we use with direction are positive or negative. Okay? So on this previous one that we were doing, okay, when we talk about direction, positive or negative, we start talking about association. So I'm going to kind of come down to here. When we have what's called a positive association, what happens there is when x increases, y tends to increase. We tend to go in a positive slope direction. Okay? Basically, above average values accompany above average values, and below average values accompany below average values. Negative associations does the reverse. A negative association, below average values will accompany high values, and high values will accompany low values. So we get kind of like a negative slope where the pattern seems to be going down. Okay? So we'll talk about it being positive, we'll talk about it being negative. The next terms that we'll talk about is the form. Does it form a linear pattern or does it form a curve pattern? The vast majority of time in this class we'll talk about it being linear. However, that doesn't mean curve patterns don't exist. But when we talk about it being linear, you'll start to see, the data kind of falling in a pattern of a line. However, you could get something that looks curved. Curved might look something like that, where you can start to see a distinct curvature to the pattern in some shape or form. The last words, okay, that we talk about is its strength. Is it strong or is it weak? When we talk about the strength, we're talking about how close do the data fall to the form of the line. So when we're talking about something that is strong, okay, they tend to be relatively close to the line. So if that's my line of best fit, my points are going to be relatively, close to that line. But weak, what might happen, here I'll have a line going negative, is the data tends to be a little more scattered, but we tend to have, make it at least look a little more negative there. That one's pretty weak. It's almost hard to see that it's positive or negative. So the points tend to be farther away from the line or from the form that we're using to describe it. You'll see me say line quite a bit because the vast majority of scatter plots that we'll look at, we'll talk about it being linear. So, if I go back, okay, to our previous problem on page 2, if we were to describe, okay, the direction, the form, and the strength of the relationship between a student's sprint time and their long jump distance, okay? Well, how I like to start them off is I like to say we have and I like to start with the strength. Would you say that this is strong or weak? Yeah. Okay. If I were to kind of sketch a line in here, and I'm just kind of estimating it, are most of the points relatively close to it? Yeah. So I'm going to say strong. We have and I might even use fairly strong. Now, do you have to have the word fairly? No. But if you say we have I'll look for strength. Strong. Now, is it positive or negative? Negative, so then I talk about direction. Negative, and then I use the form last. 95% of the time, it will be linear. It'll probably pop up one problem in your assignment where you might get something that's not. So we have a fairly strong negative linear, and then we'll say association, or we could say relationship too. You'll see me interchange those words. Association between, and then I want to put it in the context of the problem. Between a student's sprint time and their long jump distance. So, knowing how to describe what's going on, Okay, talking about the strength, the direction, and form of our scatter plots is one of the key pieces that we also want to be able to do today. So to give you just some more practice on that, let's flip to go back to our last page of notes here. At the bottom here, we gave you, or we have here for you, 4 different scatter plots. So it says describe the direction, form, describe the direction, form, and direction. But this should say, I apologize, strength. Just realize that there's a typo. Why would I ask you to describe the direction twice, but not the strength? So when I look at these, again, I also want to put it in the context of the problem. So we don't know the full context, but at least we have the x and y axis labeled, so we know what variables we're at least talking about here. So in the first one here, it looks like it says boats registered in Florida, and then the y-axis looks like manatees killed by boats. So if I look at this, draw a little line here, does it look like a fairly nice linear pattern? Okay, so we're definitely talking linear. Does it look strong? Yeah, I might even say very strong. Is it positive or negative? Positive. So we would say we have I might even say very strong, positive, linear association between the number of boats registered in Florida and the number of manatee, the 2 T's, or is it 1 T with 2 E's? 2 E's mixed. Manatees killed. Is it per year?
By boats.
By boats, okay, by boats. Alright, so trying to figure out what the next one is. It says Starnes predicted, Starnes observed. Okay. So I know that Starnes is the author of our book and he's a stats teacher. So my guess is these are predicted scores and these are observed probably scores. So it might be like scores on a test or something like that. Does it say Starnes?
Storms.
Storms.
Yeah.
Oh, okay. I apologize. I'm trying to read into it, but it's so it's storms predicted and storms observed. That makes a lot more sense, doesn't it? So this would be like a weather forecaster. So if we look here, does it seem like we still have a linear pattern?
Yeah.
It's not as strong as the first one, but is this one still pretty decent?
Can you say somewhat stronger?
Yeah. Maybe moderately strong? Okay, I like that word. So we have a moderately strong, positive, linear relationship. So now here's where I use relationship instead of association. So you can interchange those two between the number of storms predicted Okay. And the number of storms observed. So again, we have a moderately strong positive linear relationship between the number of storms predicted and the number of storms observed. So we've seen 3 examples where it's been strong, strong, strong. Okay? How about this next one? It's kind of interesting. Am I going too fast?
No.
Okay, thank you. So on this one here it says healing rate limb 1, healing rate of limb 2. Does it seem like it's going up or down? It still does looks like it's positive. Okay. But would you consider this strong? Yeah, I'd say this one's weak. So I might say we have a weak, and this one's still positive, linear association between the healing, I think it was rate, wasn't it? Healing rate of limb 1 and the healing rate of limb 2.
If the points are like really scattered like that, how would you know if it's like a positive or a negative?
Well, what I would start to look at is as my x values are increasing, are my y values going up or are they going down? So as x here, most of my x values as I start going this way are going up. This one here, though, I would start to say, as I start to pick x values, I'm getting more that are down than that are up. Because I know you could say, well, when I look here, I have some that are down, but some that are up. But when I start to look at the, lower extremes and upper extremes, even like right here, I'm starting to have more points down. But here, like on this one, I don't have any that are below it. That's why I feel that one's more positive than negative. But on this one here, it looks like we have at least, a negative association going on. But is this one strong? No, I mean, it's pretty scattered away. When you have lots of points, hopefully they start to cluster a little bit more than these are. So this one's definitely a weak negative linear association. Now it says between last year's, what is that? Percent return, okay, so it looks like we're probably talking about an investment percent return and this year's percent return. Okay. So let's just phrase that again. We have a weak negative linear association between, well, I'm squeezing twice. That's what happens when I squeeze too much. Between last year's percent return and this year's percent return. So you can see that we can start to compare all sorts of quantitative variables. All right, so I'm just going to stop the note.